Hey Tony.
Good day.
Ellie. Hey mate.
Alright. Film. Okay, this is called the decorticator, and soon we'll be doing a test of it. That was a demonstration using the old machine that does the long line. The long line stripping of the hemp, and this is a smaller version of the machine that's at Griffith at the moment. This is the demonstration we're using today. Frank went up to Griffith yesterday and he collected this amount of hemp. Unfortunately he wasn't able to get a lot more, and he said to strip all the leaves off for safety, to ensure he wasn't pulled over by anyone. I think it was another sort of a plant, but this is the hemp plant, and this is what we've been using to put through the machine this morning, and we'll be continuing to do this demonstration. We've got to get together 2 kilos of fibre for taking down to the machine in Geelong. Now the hemp getting ready to feed through this machine. Green hemp. As Adrian's just been explaining, this is the hemp from New South Wales. It's been had the leaves all taken off and had little branches on it because it was grown fairly badly, but it's still proper hemp and will work. Dave is here now filming for his benefit.
Around the other way so I don't get the sun.
David, this is from a crop that was planted after the end of the season by self-sowing, and it was cut out of that crop in southern New South Wales by Frank Urban on Wednesday, and as you can see, it's a crop that is completely affected by edge effect. It's one of the worst crops there is, but if we could have done this exercise in November, you would have had a very different crop to witness. So we're now going to put this into this prototype D7 machine and turn it and peel the skin off, and take that down and have it dig up. So we've got to get on to that now.
Give it through the whole process.
Well, we haven't in that time. We've now produced this amount of hemp fibre. About the 2 kilos that we need to take down to the Geelong system. There's some more still come out over there.
Jeordy, if you can go
And there's the hurd left over.
any of this stuff.
Do you want to talk about the split?
And the hurd down the bottom
Right.
Yeah.
under the machine.
I mean,
There's
you were saying to me
still
that we can only do this, the split.
Only we can do
Yeah.
Only we can do this. This is decorticating it green to a very high level of separation. This is the hurd. That's can be used for building material or into fuels, building materials, whatever you like, or paper. It's unretted, so paper can be made from that, whereas you can't make paper successfully out of the retted hemp. Okay.
So where are the gums at the moment?
The gums are in here.
They're in there.
Yeah. There's a lot of gum in that too, but that's a different sort of gum.
Can you just explain that a bit, the different sorts of gums? So you've got...
Oh well, you've got. We haven't analysed the different gums in this and in that, but there are different enzymes that are involved in each of these.
That's going to be the
From the hurd,
There's the gums that need to come off.
Yeah. In the bag, in the inside bag.
That's the
So this can, the hurd can actually be used as a plastic replacement for most plastics. For the fuel source, there's horse bedding. There are about 40,000 different uses for both the hurd and the fibre. And that was 20 years ago they discovered that. So probably a lot more now. Now fibre can actually be used more like a carbon with fibre replacement as well.
Either water retting or field retting, which takes anything from 3 weeks for the quick water retting to it can be 3 months for field retting. I mean, in parts of Russia they put it on the snow.
So this is doing it in a
we don't
couple
ret.
Yeah, so this is doing it in seconds.
Yeah.
What takes
Months.
yeah.
That's right.
And it separates the fibre
From the hurd. And if you put green material in, you've got green material to deal with, and we have processes for that.
Yep.
And hurd will be green, and it has its own values and disadvantages. If you want to do dry material, we degum it in more or less the same way, just uses more chemical and takes a little bit more time. But you can also use the dry material for fiberglass replacement and a host of other things.
Okay.
We've even got a market from people who want to bind up bamboo bikes with it instead of using strips of the fiberglass.
Great.
The hurd that comes out of the dry input is dry and can be used immediately in building products and whatever. Green hurd you would tend to use to digest it into fuels like ethanol or biodiesel.
Great. Oh, that's good. Thank you.
The bag I'd like to
Hemp is now in this bag.
Get a couple of bags in there.
That's great.
There. Apparently we've got 2.45 kilos of skins of the fibre. Jeordy and Ollie are now packing up the the hurd part. It should be considerably more. We are now at the International Fibre Centre at Deakin University.
Even though it's encrypted.
Right.
Worst hemp I've ever seen.
Yeah, by all means, take as many as you like. You won't get taken to anywhere where you're not allowed to take photos.
The hemp now going in there. Our system, of course, means that 90% of the hemp is recovered, of the fibre, instead of the ratting systems where only 10 to 15% is recovered. And Adrian can confirm that.
This does significantly reduce. This about 35% of what goes in here will come out the other end as a fibre,
Right.
generally. That's if you're going to reduce the fibre down to its individual components, so that you can spin it on a cotton system, you've got to remove the gums and the pectins and so forth that's binding it all together. But you've also got to take the stiffness out of the fibre, and the only way to do that is to rip all that out. Now, we do it chemically here. Eventually, I think that there's a way of doing it enzymically. It's something that I'm working on at the moment, but definitely the chemical system works, and I've got some yarns that I can show you later on if need be as well. So,
Right.
all we do with this is a pack and Sty machine. So it pumps our liquid up the centre, comes out through this pole, travels through what we're working with, and back down. This is standard to what you'd find in any textile plant. Now this one here is only a little tiny machine. The place where I was at about half an hour ago, they have their machines go up to 2 tonne, and I've seen them up to 5 tonne capacity. So you can easily purchase one of these. This is a T-Sty machine, comes from Germany. You can purchase them all over the world, and you can go straight into production with them, which is the aim that I had, was this process had to be fully scalable.
Right. And this is Chris Hurran at the International Fibre Centre.
No, at Deakin
At
University.
Deakin University.
University.
That's
I think of
where
it
we are.
as the RFC.
Yeah,
Deakin.
I think it was one of those used, Adrian. I think it was one of those that was used.
It was we used a 50 kilo one that we used at
The one that we went up, I went up that time, many of the
at Genevieve.
yeah, Genevieve, yeah, that was 50 kilos, that one. But they had ones there, 250, 600 and 500 were their main bats. But I've seen one in China that was 10 tonnes.
Yeah, oh, they're massive.
How long does this process take?
2 hours, eh?
2 hours?
You think that would be 2 hours?
The biggest problem with this is that all the hoses on it are UV degrading.
Oh,
And every time I run it, it took me about an hour this morning to repair the hoses that had ruptured in between the last time and this time. That's just frustrating. But to replace this machine, you're looking at about 100,000 to buy one off the shelf, and there's very little difference between this one and the latest model. Like, this is a 96 model machine, and the technology hasn't really changed that much in package dyeing. They run very low liquor ratios. So all I'll do is I'll fill it up with water, we'll add our chemicals, heat it up to 120 degrees Celsius for 1 hour, cool it back down again, and then I'll give it 3 rinses, and then the fibre will come out at that point. So,
Did this do gum up to the same point as last time?
It should be better.
Should be better.
I mean, Chris developed, I suppose, was
What are we doing? We're filling it with water now.
yeah, so it's just filling up. It's very slow because I've only got a domestic supply coming in.
Okay.
It's coming out.
It's set up for research. No, but this machine heats very, very quickly.
Yeah, it's going to take off now.
Got a good little do a lot with Gordon. We have a bit of a transition between the two places, and we've done a little bit of work on conductive polymers, but nowhere near as much as what Gordon's doing. Now, just from my eyes, I'm going to wear some safety glasses. I might give you guys to step back a little bit. Boring for the next 2 hours. Because all it does is make noises like that with the occasional whoosh of air.
So what part of this process was the development side?
I've done a lot of work with what we put in there. And also steps after this, some of the ways that we treat it after this. The right chemicals in there are quite crucial. That one that doesn't have a label is probably the most crucial, and the concentration of that is very important. And the others, stock standard, you can go and have a look at any baseline chemical rating of hemp and you'll find that they all use similar sorts of chemicals. But it's that one there that makes a big difference.
And that, are there any nasty chemicals that come out of the process, or is there
This one, at the moment, with chemical reading, you have quite a heavy effluent load, but it's something I intend to do in the very near future, is to do multiple rettings with the one bar. There's no reason why you couldn't do that. The other thing is getting a degree of a thickness out of the liquid. When you bring it out of here, there's a huge amount of vegetable matter within it in the way of dissolved pectins and cellulose and hemicellulose and so forth. So if you could put them through a quick filtration to get the bulk of that out, there's no reason why they couldn't be put back in, and you could do the chemical reading with it again, possibly a number of times, and that's something I intend to do in the very near future. It's got to be right. And then eventually, I'm working at the moment now on some better systems, and hopefully what we'll get down to is something that has zero emissions. Hopefully what emissions do come out of it can be used for biofuel related matters.
What's the worst thing that comes out of this one?
High pH. So high pH. So it's an alkali that we're using for the reading.
The gums that come out, are you able to reuse?
At the moment, no, but once again, that comes down that path that we want to go down with. So what comes out of this at the moment, I haven't done biofuel related work with it. I think it's got such a large component of nutrients in there, and such a large cellulose biomatter within there and so forth. There should be a way of fermenting that down and making biofuel out of it. I've got someone working with the hurd at the moment making biofuel, but I think that the byproducts of this definitely could be used. And if you're making waste, you may as well try and get some money out of the waste if you can. But I definitely think that, I haven't proof of it, but I'm sure I will in the not too distant future, that we'll be able to reuse the main reading bar a number of times, maybe with a small addition of chemicals each time rather than putting in a large aliquot each time. So that should make a big difference. And with these automated machines, you just have a tank out the back of the same volume as the machine, pull it out of the machine and through a filter into that tank and then back in again.
There's nothing, there's just high pH, there's nothing else.
No, there's no phosphates, there's no absorbable organic halogens or anything like that. There's a small amount of detergent, so you know, the organic matter that you're putting in there is a small amount of detergent. It's totally an inorganic process. As I said before, it's mostly an alkali. I was looking, there's another company that uses potassium-based salt in theirs with the aim that they use that for use in a field or something like that. But it's interesting the amount of potassium that they're putting in. I think it will make it very hard to do that reuse. This one here, if we can get reuse of the bars, then it makes it quite a good process. But
earlier
it just needs to have
those engineers are ready to do it.
Well, you can filter to a certain extent, but you can't filter like you won't get everything. You'll get the thing you want to have is a way of taking out the biggest, ugliest bits. If you go and try to get everything, you're going to gum filters up and you're going to use huge amounts of filters and that sort of thing. If you can get a filter medium where you can get the bulk of it out, the biggest stuff out, and then you can reuse, then that's the way to go. And once again, you take that and you treat it separately, and definitely that first bath and the second bath are really, really full on gum. And like you'll see that already. Like if we get the daylights out of me. If you look at that already, you can see the colour that's coming out in that once it gets to the end of its redding cycle. That's at 80 degrees Celsius now. Once that goes through the full cycle and comes out, that'll be very thick. Because you're pulling, as I was saying before, there's 35% of what's there will remain there. In this particular step, we'll probably pull 40 to 45% out, and then the subsequent rinsing steps after that will take the rest. So you're putting a fair amount into that water.
The important thing in this is that virtually all the fibre is recovered, is what Tony was mentioning before. Whereas if you go through a field retting or a water retting process in the traditional way, what you can actually turn into cloth at the end of the day through those old 100-year-old systems is around 10 to 20% of the fibre that is standing in the field.
The beauty of this system is you don't have fibre breakage. So the traditional system where you retted it in the field, you brought it in, you scutched it, was a mechanical process that gave you your separation. You got a degree of separation with the dew retting in the field, and you still had a lot of gums holding things together. So when you with mechanically scutched, you get a lot of fibre breakage where you grab a fibre and rip it off and that sort of thing. What we've got here, what comes out of here is fully separated. So when you put it through the carding process, there will be a very small percentage of breakage, but it will only be very small. So what you're doing is you're running, come straight out of here, you go through an opening device that opens it up, and then you go straight into a cotton carding system or a cotton blow room where the remainder of any hurd that's left in the actual fibre will be removed, like cotton trash, and then you'll go through there into a flat top card, and it'll be carded like a normal cotton fibre. Because you've got individual fibres, not perfect individual fibres, to get individual fibres you've really got to knock it around. But because you've got a lot of very small diameter, quite short fibres similar to cotton, what will come out of the card is pretty much all that you put in there, apart from the hurd remove. And you might be looking at 2 to 3% losses going through a carding system, where going through the scutching system, you'll have huge losses. And they get that out of short fibre, and they do chemically separate that and then use that for spun yarns, but it's not as good because it is generally quite short fibre. Where here, what we're getting out is pretty much identical to cotton in length.
And that's because of the way that it's comes through the machine.
Yeah, well, you're removing the gum at this point. You're not using any mechanical action to remove that gum.
Yeah.
So you're not bashing it apart.
Or gums here, then it can go without any more mechanical.
So the next mechanical step it'll see is just banging it apart.
Yeah.
Now the beauty is it's just not held together anymore. So when you bang it apart, it just falls apart.
When you do the long line, the traditional way, you've got two sorts of fibres in this. You've got the toe, which is short fat fibre, and the long line, which is what they make the finer linen out of. Now, to start with, you take out the toe and you've lost half the fibre. And here, with our system, this is indistinguishable. It doesn't matter if it's toe or it's long line. It ends up the same, because the toe is made up of building blocks. The long line is made up of the same building blocks, they're just in different configuration. Now this system makes them all the same, so there's no losses to toe as there would be in the long line system. So we win on every level.
Okay, so the difference between this and what else has been done is what you don't need the mechanical process.
The beauty with this is you have one of these machines here, you have a rinsing and dunking system to get the remote, because what we get out of here still has, what we do here is we're actually doing it while they're all sitting next to each other. When you pull it out of here, there's still a degree of rinsing needed to actually give you wet separation of those fibres, because in here, you watch me, I compressed it down, there's no movement. So the next step of the process is to give you movement so that you can get those fibres separated. Then the next step of that is just a standard cotton production system. So if you go down the long line system or you go down the traditional spinning system, you've got to have the traditional spinning equipment. And the difference is hemp accounts for 0.01% of total textile production, where cotton accounts for 30-odd%. So 30-odd% of the money invested in machinery goes into working on cotton machinery, 0.01% goes into working on hemp machinery. So you can tell which one's automated and developed and that sort of thing. So,
I've been to
so production
Mackie factories to see all this.
yeah, so production-wise, you're producing a fibre that can then be spun on the most economical spinning equipment that's available.
An example is, I've forgotten what the volume is, but a Treutler card costs you $200,000. The equivalent Mackie hackler to do the same volume of hemp is £3.5 million when Hamish and I went to Mackie.
The biggest thing that I was looking at, you've got to look at economies of scale. If you're ever going to bring this into the mainstream, it's got to be done on the standard production equipment. And that's why I went down the path of individual separation, or separating out so that you had something that was like cotton. Because there's so much development on cotton. Like I've got a little open-end spinning frame over there that we spun some hemp on a while ago. And it's an old machine, but you go to the latest version of that, it's all robotic. You bring your drum of tow over, you put it in the machine, and the robot comes along and changes a cone whenever the cone's full, and if it breaks the yarn, it pieces it up automatically. And you can actually set it up that when it comes off the end of that, it goes onto a conveyor line and goes automatically into the next process. So you've got all those economies of scale that you can then go straight into full production. The other beauty is you'll find cotton production equipment all over the world. And there's multiple manufacturers for cotton production equipment. Where you go to the hemp side of things, there's Mackie. And you might find there's a couple of Eastern Bloc countries that make them as well. Yeah. So it's really, really, really hard to find the equipment. And when you find it, it's old technology, really, really old technology.
Really old, and finding somebody who can manage it, somebody who can run it. This is what happened to the Canadian company, Consolidated Processors and Growers. They bought all this old equipment. Then they couldn't get anybody to even assemble it, much less run it. And that was the end of $20 million. Whereas Chris and Jeordy convinced me within 5 minutes that this was the way to go when I first came here. For all those same reasons.
So what we've developed here is something that works. The next aim is to make something that's more friendly as we go along. So this gets you into production, and then hopefully in 2 or 3 years' time, when the development's right, you've got the most environmentally friendly production to go forward with.
Chris and I are sort of joined at the hip with this whole thing in Deakin, and because this is where it really got its first start. This is where I expect to do all the development further on.
So we've been there for about an hour and a half or so.
Yeah, so that's at 108 degrees Celsius now, so it's still got, it'll have 60 minutes at 120, which it'll get to in about 5 minutes' time, so it's a good time to have lunch or whatever. That's okay. When it gets to cooling back down again, I'll grab a sample of water so that you can have a look and see what it looks like.
That's the first.
It's quite dark, isn't it?
Oh yeah.
Called what?
Blackwater.
Is it drinkable?
Similar to what you get in the
Potent?
If you hit it after 2 glasses,
Up to 2 glasses, you're on your ass.
I'm going to say something. They would have created something. You worried?
Excited?
Yes.
So I'm staring me up.
What?
cooled it to 60, not 70.
Sorry?
I should have cooled it to 60, not 70. It's nice and warm. So it's very sticky at this stage because it's still got a lot of the... what we've done is we've softened the gum and broken it down. We haven't removed it totally. And that's where the dunking step is quite important. Remainder is hurds.
Do we follow you or? Yeah, it's not on there. Is that all? I'm glad you took that out. Did you? It was on the news last week. They want to take out the bubble black sheet from the Intenational.
Oh, really?
Yeah, because it says polyethylene thread, so it's not a swab or a rainbow sheet.
No way.
That's smart.
Well, rainbow gets something else.
Well, I know, thank you, I know. It's all normal.
Thank you.
I'm glad it's not on.
It is.
This is really not.
So this is the pasta maker.
So this is a pad mangle. All I'm doing with this is just squeezing out the excess moisture. I find doing this helps to squeeze out some of the bits and pieces that we're trying to get out. It's also, the aim is that it's very similar to a process of wool scouring, where you go through a squeeze roll and then you go through a dunking system. So once again, trying to utilise equipment that's already out there, developed, easily purchasable. I'm going to have to wind the pressure up on these.
The stuff that we did, Adrian, that time, that was dried already, wasn't it?
Yeah. Yeah, we did it from dry.
Does it lose its colour?
Oh, this will lose its colour, yes, we're going along.
It's cream.
Goes cream, yeah, like the other stuff.
We found it's when we do it green, it's cream with a slight green tinge. And when we do it from dry, it's just cream with a sort of yellowy tinge. But it's instantly dyeable in standard cotton dye processes. And it dyes to very light colours.
So using the same
Process of it.
Same process,
Cotton dye,
same chemicals.
Yeah, pre-bleach with a stabilised peroxide, and then you dye with just standard cotton reactive dye stuffs. Right.
Because it's cellulose, it's the same.
Yeah.
I have had somebody dye it with wool dyeing processes too, and that was quite successful.
So you don't have the problem. So it's the same pH as cotton or wool.
Colouration's identical to cotton. It may as well be cotton. We can dye it alongside cotton.
Now when you do it the field dressing way, there's all minerals stuck all over it. And when you dye it, those, when it gets worn and washed, those minerals fall off, and with it they take dye. So that's why old hemp clothing that's been done in that way tend to have this sort of uneven mottled look.
Yeah.
Whereas when it's hemp done this way, it's the same as cotton, it's just stable as cotton, it doesn't have that drawback.
Is there anything about hemp that there could be developments there in the dyeing? Or is it
Not
to get
really. It's
different dyes?
It's got exactly the same problems as cotton when it comes to dyeing, in the fact that it uses large volumes of water. It's a cellulose, so there's not really a great number of bonding sites on there, so the dye doesn't want to be on it.
Yeah.
I think I'm in the process of doing a review of dyeing processes at the moment. There's no nice dyeing process. No matter what fibre you look at, they're all water intensive, energy intensive, chemical intensive. Cotton's the worst out of the lot in the fact that it uses the most water and has the most amount of colour left afterwards. I just think from the analysis I'm looking at the moment, the amount of colour is going to reduce in the world. I think you look at colour being a chemical, like you look at all your dye stuffs, they're all chemically derived dye stuffs. It's going to have to reduce down. There'll still be colour.
Yeah. That's an interesting thought. So all the high
volumes
coloured polyester dyes and all this sort of thing you need as well? Or?
Well, there'll still be a little bit of polyester done, or synthetics done, only because of the fact that you can mix the colour in when you melt it. So you can start to dig mineral earths with colour in them, such as your red ochres and things like that, put it into the melt and colour it that way. So in all, polyester is actually the nicest to colour. It uses the least amount of water in the bath, and you can also colour without wet colouring. Because it's wet colouring that's the problem. Well, in the interest of the time that we have, I think that we'll do it volume-wise. I'll go and dump that. No, so I'll leave that beaker there. Get another container to bring this lot back in, because we've run up through the squares a couple of times. Just go swap laboratories, that's all.